All right, this is section 3.5, and we're talking about writing equations of lines. So this is section going to be about how do I write the equation of a line. I apologize. So what have we done so far? So far, what we've learned how to do is take a linear equation like y equals 3x minus 1 and turn it into a graph. So that's kind of what we were doing in section 3.2, 3.3. We were just trying to figure out how to turn lines into graphs, essentially. So if you gave me y equals 3x minus 1, I can turn that into a graph. If you give me 2x plus 3y equals 6, I can turn that into a graph. I can turn a line, a linear equation, into a graph. And how do I do that? Well, I would pick 3 x's, get 3 y's, make ordered pairs, graph the ordered pairs, and draw a line through them. If you need to go back and look over that, that's in section 3.2, I believe. 3.3 is intercepts, so 3.2 would be the section you look at. So 3.2 is where you look at to see how do I graph y equals 3x minus 1 and turn it into a graph. Now, what we want to do, where we're going, is this. You saw how we took y equals 3x minus 1 and we turned it into, so we saw y equals 3x minus 1 and we turned it into that. We're going to go backwards. So what we're going to do is instead of going from a line or an equation right here to a graph, we're going to go from a graph to an equation. So we're going to take a picture and turn it back into a line. So we know that is 3x minus 1, but now we're going to talk through and walk through how we know that. So I'm going to do some introductory stuff, and then we're going to introduce a formula, and then we'll come back to what we did before to talk about kind of why I talked about this other stuff at the beginning. So right now we're just going to talk through some stuff, and then we'll get to a formula. One thing we know about a graph is we know that it has 3 points. What are the 3 points? It's 0, -1, 1, 2, and 2, 5. So if I trace that, I go 0, -1, 1 over 2 up is 1, 2, 2 over 5 up is 2, 5, okay? So I know those are the 3 points it has. Well, how do I know those points? I look at it and I just sort of go 0, 1, 1, 2, 2, 5. So again, that goes back to section 3.1, where we are identifying points and we're trying to figure out what quadrant things are in and all that kind of stuff. So where are things located on an XY graph? Let's practice that a little bit. I want to identify points. So what are the points pictured in the graph on the right? Well, let's see. We've got 1, 2, 3, 4 to the left, -4. 1, 2, 3, 4, 5, 6, 7, 8, 9. -4, 9. So -4 to the left, 9 up gives you -4, 9. I apologize. All right, 1 over 1, 2, 3, 4 up is 1, 4. Or if I go 1, 2, 1, 2, 3, I get 2, 3. So my points are -4, 9, 1, 4, and 2, 3. Those are my 3 points. All right. Work a second example. What are the points pictured in the graph on the right? The points are -2, -1, 1, 5, and 3, 9. So -2, 1, 2, down 1. So over 2, down 1 is -2, -1. Then we have 1, 5. Then we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 9. So again, we're just identifying the points on the graph. Okay. Now, there are 2 ways to write a line. The 2 ways to write a line, number 1, is called standard form. Standard form is ax plus by equals c. 2x minus 7y equals 10. 3x plus 7y equals 8. X and y are on the same side. The second way, the main way that we run a line, the way that's most useful to us is called slope-intercept form. That is y equals mx plus b, where m, as it generally does, equals slope. So when we say m in math, 90% of the time, we're talking about slope. Sometimes we use m for other things, but a lot of times when we want to talk about slope, we use the letter m. All right. And of course, we just know the difference between the two forms essentially is that in slope-intercept form, y and x are on different sides. Also, y is by itself. And that's going to be important to us as we move on. All right. We got slope-intercept form. We got standard form. Y equals mx plus b. Let's see 2 examples. All right, example number 1, y equals 5x minus 9. Example number 2, y is equal to negative 4x plus 10. Those are our 2 examples. So if we see it looking like that, we know that that is slope-intercept form. So like y equals 2x minus 3 is slope-intercept form because y and x are on different sides and y is by itself. So that's what we know. Slope-intercept form. All right. The main formula we're going to use to figure out the equation of a line is the point-slope formula. This is the point-slope formula here. Most of the time, those parentheses on these parentheses right here, these parentheses that I'm pointing out, are not present in the formula. I don't like the fact that I have those there. That's actually kind of distracting. So whenever I write the formula, I will not actually write these parentheses over here. I will, however, write the parentheses on the right side. So those are necessary, these are unnecessary. But we'll work some examples. Just know that this is not quite the way that I want you to write it. All right, again, m is slope, x1, y1 is any point on the line. Remember, a point is just ordered pair. An ordered pair is composed of an x and a y. So every ordered pair has an x and a y. All right. So whenever I want to write the equation of a line, I use the point-slope formula. All right. There are 7 steps. The 7 steps are, we label the ordered pair as an x1, y1. Remember, ordered pair is the same as a point. The slope is m. All right, step 2, we write out the point-slope formula, which I will call the PS formula from now on, because I don't want to have to write point-slope all the time. And the formula is y minus y1 is equal to m times x minus x1. Step 3, we fill in the x1, the y1, and the m. We do not fill in the y part or the x part. So this y and that x will not get filled in. If we have a minus next to a negative, we turn them both positive before doing anything else. So if we encounter any minus negatives, then we have to deal with that first. And 5, since we have parentheses, we need to distribute. So we distribute on the right side of the equation, i.e. multiplying. That's all distributing is, multiplying. So in order to get the equation into slope-intercept form, we need to get y by itself, because when you have slope-intercept form, y is by itself on the left side of the equation. Now, if the equation is in the form y equals mx plus b, in other words, y and x are on opposite sides, and y is by itself completely on the left side of the equation, then we are done. And that is our final answer. Until y and x are on opposite sides, and y is by itself completely, until that happens, we're not done. If y is not by itself, we're not done. If y and x are on the same side, we're not done. We are done when y and x are on opposite sides and y is by itself completely on the left side of the equation. Then we are done. So let's keep going. Example number 1. I'm gonna walk through it's in words, then I will show you a picture of the same thing. So the first thing we do to find the equation of the line, okay, that means we're gonna use point slope formula because it's the equation of a line that passes through the point 1, 4 with a slope of 2. The first thing we do, we label the ordered pair 1, 4 as x1, y1, and the slope is 2 is m. We start with the point slope formula, y minus y1 equals m times x minus x1. We fill in the x1, the y1, and the m. So notice that I didn't fill in the y or the x. I filled in the x1, the y1, and the m, nothing else. I don't fill in the y and x part. I distribute, multiply on the right side of the equation. So 2x minus 1 is 2 times x minus 2 times 1. Gives me 2x minus 2. The equation becomes y minus 4 is equal to 2x minus 2. But we're not done yet. How do I know? Because y is not by itself. There is a minus 4 on the same side as y. I don't want that. So the final step is to get y by itself. So we cancel out the 4 by adding it to both sides as such. We say minus 4 plus 4 minus 2 plus 2. We do the same thing to both sides because that's one of our basic rules in algebra. So y, these cancel, 2x minus 4 plus 4, and we put that in our calculator, we get plus 2. All right, let me show you the same thing as I would work it. So y, so the first thing we do is we write our formula out, we label our points. I label my point x1, y1. I have a slope of m, I call it m. I write the formula, y minus y1 equals m times x minus x1. I fill in the x1, y1, and m part. So notice the y1 is 4, the m is 2, the x1 is 1. I don't fill in the y, I don't fill in the x. Then I distribute. So I have to get rid of these parentheses over here. 2 times x is 2x. 2 times 1 is minus 2. Okay. And then I get y by itself. So minus 4, we add a 4 to it. We add a 4 on this side because we have to do the same thing to both sides. And we get minus 2 plus 4. Now, notice that 2x doesn't combine with plus 4. There's a reason why 2x doesn't combine with plus 4. They're not like terms. And because they aren't like terms, they can't combine together. When you add the 4 to both sides, you only add it to the number that's by itself. 4 is a number by itself, minus 2 is a number by itself. So therefore, the plus 4 can only be added to the number that is by itself. 2 has this 2 has an x next to it. It can't combine with that because that doesn't have an x next to it. So the plus 4 only combines with a number that is by itself, the minus 2. It does not combine with the 2x. So we take that one step and we get y, because these cancel, is equal to 2x, put that in our calculator, plus 2. Now, we look at it. Are y and x on the opposite sides? Yes. Is y completely by itself on the left side of the equation? Yes. Therefore, we have done, you can basically say, you check that off and say, cool, check. So we have our final answer. Because y is by itself on the left side completely, and y and x are on opposite sides. Example number 2. This is the second example. I want to find the equation of a line that passes through the point -1, -3, and has a slope of 4. So Yes. So first we label the ordered pair as -1, -3 is x1 and y1. 4 is the slope, we call it m. We write out the point slope formula. This is how we learn it. The way we learn the point slope formula is by writing it out over and over and over again. We write it out until our fingers are tired and our pencils are not sharp anymore. So we just keep writing it out. Y minus y1 equals m times x minus x1. We fill in the x1, the y1, and the m. We don't fill in the y and the x. So we fill in the y1, the m, and the x1. We fill them in, we put them in their appropriate spaces. Notice we have a minus next to a negative. Now, negative numbers are surprisingly difficult to deal with, even for people who do a lot of math. So we try very hard to avoid them because negative numbers, they play by a different, not a different set of rules, but they seem like they play by a different set of rules than positive numbers. So we try to get rid of negatives as much as possible. We can't usually get rid of them, but every now and again we can. And here's a time when we can get rid of negative numbers. We have a minus next to a negative. Now remember that a negative times a negative is a positive. So that means that this minus minus, our minus negative, can become a positive. So we basically take this and change that and that to a positive. Now we also have a minus negative over here. We have a minus and a negative, but that's going to be confusing in the future. We don't want to deal with that. That's going to be really confusing. So let's get rid of that immediately. We're going to squash that. So the way we're going to squash that is by turning a minus negative into a positive, into a plus. That's going to make it easier for us in the future. All those weird mistakes that we make when we deal with negative numbers, we won't have to deal with them because now we're even subtracting a negative. That's a whole nother thing. If we can actively avoid having to subtract a negative number, we should. So if we have a minus negative in anywhere in our problem, the first thing we do is turn it into a plus. All right. Cool. So now that we've done that, now that that minus negative down there, up there, has become a plus, and this minus negative has become a plus, we can now have an easier problem. So we go to step number 5. Step number 5 tells us that we get rid of the parentheses by distributing on the right side. So 4 times x is 4x, 4 times 1 is 4. So now we have y plus 3 equals 4x plus 4. Are we done? No, we are not done. How do I know we're not done? 2 things. Number 1, y is not by itself. I know we're not done because y not by itself. And number 2, it's not in slope-intercept form. Slope-intercept form looks like y equals blank x plus blank. Well, we don't have that. Y is not by itself. We're not done. But we can be. So what we'll do is we will get rid of the 3, the plus 3, by subtracting the 3 from both sides. And we'll do the same thing to the other side. And that'll give us 3 minus 3 is 0, so that goes away, it's gone. And we get 4 minus 3 is 1. So this will go away, 4x plus 1. Now we look at our answer. I got y equals 4x plus 1. Y and x are on the opposite sides, check. And y is completely by itself on the left side of the equation, check. We have achieved both of our goals. Our final answer is y is equal to 4x plus 1. All right, this is essentially the same thing. We label our points, x1, y1, slope is 4. We plug in y1, m, x1. When we plug that in, we get minus negative. But before we do anything else, step 4, we turn minus negatives into pluses. So this minus negative becomes a plus. Step 5, we distribute 4 times x, 4 times 1. Step 6, we get y by itself by subtracting 3 from both sides. Step 7, we check and see if we're done. Is it in the form y equals mx plus b? Are y and x on opposite sides? And is y by itself completely on the left side of the equation? Yes and yes. We are done. That's our final answer. We put a big box around it. Hooray. Okay. Whew. All right, cool. All right, this is example 3. I'm gonna skip this slide here. You can go back and read that slide. I will go to the slide where I just work it out on paper. And then we will kind of finish up. All right, so again, same idea. We label the ordered pair, x1, y1. Remember, every ordered pair has an x and a y. The slope is m. We write out the point slope formula. That's the point slope formula. That is your point slope formula right there. Y minus y1 equals m times x minus x1. That's your point slope formula. All right. We fill in the y1, the m, and the x1. All right, let me back up here real quick. I want you to notice that on one of the previous slides, there were parentheses around y minus y1. Don't do that. Don't put parentheses around y minus y1. Put parentheses around x minus x1. Do not put parentheses around y minus y1. I apologize for the confusion. That's a really bad way of writing it. Just write it this way right here. The way that I've been writing it. Y minus y1 equals m parentheses x minus x1. All right. That's just a note. I just want you to know that. I'll go back and say that again. I really need you to not mess that up. So we have y minus 5, because y1 is 5. We get that from here. We label our points so we know where everything is. M is 2. We know it's 2 because we labeled it. X1 is 4. We know it's 4 because we labeled it. All right, we fill in the xy, x1, y1, and the m. Do we have any minus negatives? No, we don't. So step 4, if we did have a minus negative, we totally would turn stuff positive. But do we have any minus negatives in here? No. I mean, do you see any minus negatives? I don't. I see a minus. I don't see any minus negatives. I don't see anything like that. So I'm not going to make anything positive because that didn't make any sense. There are no minus negatives for me to do that with. If I had a minus negative, I would do it. I don't have any minus negatives, so I'm not going to turn anything positive. I'm just going to leave it everything the way it is. Cool. So step 4 that we did for the last example, we don't have to do it. We don't have any minus negatives. We don't have to do that step. We just skip it because we don't have any minus negatives. All right, great. So we can just skip that whole step 4. All right, step 5 though, we cannot skip because we have parentheses. So we distribute. 2 times x is 2x. 2 times 4 is 8. So we get 2x minus 8. And last but not least, step 6, in order to get the equation into slope-intercept form, we need to get y by itself. So we add 5 to both sides to get rid of the minus 5. Remember, we do opposites. So we add 5 to both sides. We add 5 on the left side and the right side, because we have to do the same thing to both sides. Whenever you do to one side, you do the same thing to the other side. That's the golden rule of algebra. So we do that. We get minus 5 plus 5 minus 8 plus 5. We get y is equal to 2x minus 3. Now we check and see. Is that our final answer? Is that it? Is that all we have to do? Let's think about it. What are our 2 criteria? Number 1, y and x have to be on opposite sides. Yes, they are. Y is on the left side, x is on the right side. Y needs to be completely by itself on the left side of the equation. Is y completely by itself on the left side of the equation? Yes. Y is completely by itself on the left side of the equation. We are done. That's our final answer. We can circle that, we can box it, put a star around it, we can put stars on it, we can highlight it, underline it, and everything else, because that is our final answer and we are done. Cool. And that's it. There are a lot of steps that you have to kind of think about, but that's why you practice these and you keep working on them. And you have the homework that I'm going to assign as well, so you'll have time to work on that as well. Cool. All right. So, to recap, in our final example, we had a line that had a slope of 2, right? N equals 2, and a point 4, 5, that's 4, 5. It has a slope of 2 and a point 4, 5, and we took those two informations, those two pieces of information, sorry, and we used it to figure out what it looks like as an equation. So we went from a graph to an equation, which was our whole goal for this entire thing. How do we go from a graph to an equation? How do we go from information about a graph to an equation? That's this whole section. And in the next section, we're going to continue, and we're going to talk some more about how to go from a graph, or information about a graph, in this case, a point and a slope, to an equation. And so we're going to do that in our next section. Let's summarize it real quick. We are trying to go from a graph of something to an equation of a line. Whenever we want to find the equation of a line, we use the point slope formula, which is right here. The form that we want our answer to be in is called slope intercept form. And the steps to going from a point and a slope to an equation are listed on the right. And you just have to go through those, work a bunch of examples, watch some YouTube videos, and do whatever to try to figure that out. All right. I will assign homework on this, so you'll be able to practice this some. And cool. You guys have a good day.